Okay, so we're taking a quiz tomorrow, 3-7 and 3-8. We might actually be able to squeeze 10 problems in this one instead of having a 5-question quiz. All right, so it'll probably be 10 questions, 20 points. Like even if it was a 5 question, it'd still be 20 points. All right, but that's what we're gonna do. Yes, ma'am. Say that again. I still have it. It's not graded. Do you want it back? I can give it to you. If you need it, get it to me at the end. Well, after we go over this, I can give you 3-7 back if you want it. Does anybody want the 3-7 back? I haven't graded it yet. Sorry, it's still in my folder, but I can get it back to you if you want. So get in here. I'll give them to you. You can pass them back to whoever wants them. I had a very busy day yesterday, and it wasn't just the Eagles game. I did watch it, yeah. I watched the whole thing. All right, just see who wants their homeworks back. But you can turn them in tomorrow. I won't mark it late or anything because you already turned it in. All right, so basically what we're going to do today is just, well, we'll start off going over 3-8 right now. So let's see, review for quiz sections 3-7 and 3-8. So let's just go over the homework. I read off the answers to you already. So you had some questions from 20 to whatever it was, 24. All right, I don't have the book open in front of me, but I do have the work that I did for it. Same. Who's got the book open can read it off to me. Okay, read off what the problem says. Yeah.
If y varies directly as x.
Okay, stop right there. It says y varies directly as x. How are we writing that?
Y equals ck or
Yep. Okay, keep going. There's more.
and inversely as a square of z.
Okay, stop. And inversely. Okay. What does that mean? What are we going to do if it says inversely? Well, we already got the x next to the k. It's on top. Inversely as what? The square of, or what is it? The square or cube?
Inversely as the square of z.
The square of z. Inversely as the square of z. Right. And there's the square of z. It's inverse, right? So it's on the bottom. So this one is directly, the x is directly, so it's on top. The z is on the bottom, the z square is on the bottom because it says it varies inversely as the square of z. Everybody see that? All right, so even though it's two different things, this is how you would write it. So that's how you're going to write the thing. And they give you a couple things, don't they? They tell you what y is. 1/6.
When x equals 20.
Yeah, when x equals, and they also tell you x equals 20 and z equals 6. All right, so this is all the stuff they tell you about this little equation right here. So what can you find? If they tell you y, x, and z, or x, y, and z, what can you find in here?
Z squared.
The k. Right. Look, they give you x, they give you y, they give you z. What's the only thing you don't know? The k. So I'm going to solve for k. Now, you could, if you wanted to, everybody's listening, right? You could plug everything in right now and then solve for k. But what was my suggestion to you? Is to do what? Find k first. Okay? Get k by itself first. Do you have to do it that way? No. But I think, because I can kind of see in the future of what you're going to do later, that this is going to be beneficial to you. All right? So what I would do is I would get k by itself. So what are we going to get rid of? Get rid of the z squared first, right? How do I get rid of the z squared? Multiply it. Right, it's on the bottom. It's being divided, right? So how do I get rid of something being divided? I multiply. So what am I going to have over here on the left? I'm going to have a y and a what? Z squared. Okay, so I got rid of that. Again, I'm trying to get k by itself, right? So what else am I going to get rid of? The x. How do I get rid of the x? Divide it. So that is equal to k. Or if you want, you could put the k right there. That's not too hard, is it? You should get used to that, okay? Get used to this. This is why in Algebra 1 and Algebra 2, they give you these crazy things with all these variables, and you got to get one of them by itself. The whole reason they want you to do that is because of something like this, okay? It's not the only time. When I really think about doing stuff like this, I think of physics. I talked about that the other day. In physics, there's times when you get this big, long equation, they give you a whole bunch of stuff, and you got to find some variable that's like in the middle of that equation, right? And it's way easier to solve for that variable first, and then when you're done, plug everything into it, all right? So get what you're trying to solve for by itself first. That's my suggestion. I just think it's easier. You may do it both ways and say, well, Mr. Hammer, it's really not easier. But eventually it will be. So I just want you to get used to doing it this way. All right, so what do? We know all that. We know x, we know y, we know z. It's right here. So let's plug everything in. So the y is what? 1/6. What is the z? Right, 6 squared over the x, which is 20. And now you just work this out. 6 squared is 36, and this is 1/6 of it, or 36 divided by 6. So what does that come out to be? Just a 6, okay, over 20. And then you just simplify that, and it's a 3/10. That's right. Okay, or if you wanted to, since it's an easy decimal, doesn't round. Excuse me. It doesn't round or anything, so you could just write it 0.3 if you wanted to. It doesn't matter. Make it 3/10, make it 0.3, doesn't make any difference. I think it's a little easier, I think, to use the 0.3. Are we finished, though? No, because we just found what k was equal to. Now, they give you more to the problem, don't they? They say find what? Go ahead, Sam.
Find y when x equals 14 and z equals 5.
Okay. All right, so it says find y, so that's what you're looking for, when x equals 14 and z equals 5. So you're going to go back to this equation that you wrote down, this proportion, okay, and you're going to solve for y. Well, check it out. Y is already by itself, isn't it? So that's cool, so I don't have to worry about that. So I just plug everything in. Okay, I know the k now. That's why I went through all this stuff, so I could find k. So I'm going to put 0.3 right here times x. What's our new x? It's 14. And then our new z, which is 5. And then we got to square it because this is z squared. And you punch all that in, and you get 0.168. And that's your answer. I'll put y equals. These are pretty basic, aren't they? Yeah, it's about time, isn't it? We had something that was kind of like algebra-ish. Yeah. But this is the key, I think. That's a really important part to make sure that you set it up right. Okay, again, what does this say? It says y vary directly as x. So you write y equals kx, and then inversely as the square of z, or of z squared. So inversely means we're going to put it on the bottom, and z squared. Make sense? All right. What was that, 20? Okay. I don't want to do every single one of these, but we could do at least one more. What else you got? 24? The very first one? Number 13? Okay.
It was y equals 1.2.
Tell you what, we'll do two more. Give me something else between 21 and 23. We'll do 24 at the end. 21? Just go to the next one. We'll definitely do. All right, so let's do 21. All right, Sam, read it to me. Y varies what?
Suppose y varies jointly as x and z.
Okay, stop right there. It says y varies jointly as x and z. So that's a direct variation. Okay, it doesn't say inverse, so you're not going to put it in the bottom. So it says, and jointly means you're going to have two things in there. Okay, so when it says jointly like that, it's a direct variation, but you're going to have two things in there instead of just the one thing. So it's not just y varies directly as x. says y varies directly as what? X and z? Is that what it said?
Yeah.
All right. So that's how we started off. And then what else does it say?
And inversely as y and w. As w.
It's just w, right?
Or w and y. So.
It says w and y?
Oh, sorry.
No, it says and y equals something, right? Yeah, and w. So there's your variation right there. Okay, so that's how you want to start that off. Does that make sense? All right, so y varies, what does it say, jointly as x and z? All right, so that's how you'd write that part, and inversely as w, so you put that on the bottom. All right, and they tell you a whole bunch of stuff. They tell you 4 things, don't they? All right, what do they tell you? Y is -3 when x is 2, z is -3, and w is 4. All right, so I'm going to stop right there. Now, it tells you other stuff. It says find something. Find y when x, y, and z are all these different numbers, okay? But we want to find the k. That's what we're concerned about, okay, is that coefficient.
Jaden Bunting, your shadow to office, please. Thank you.
All right, so what we're going to do is, let's get k by itself first, okay? You could plug all the numbers in if you wanted to, all right, but I like to solve for k first, and I think you should too, all right? So let's do that. Did anybody do that? Try to solve for k first before they plug the numbers in?
No.
Okay. You would have? Just didn't know what to do? Okay. So let's solve for k. K equals, what are we going to do?
Multiply by w.
Yeah, I've multiplied by w, so you're going to get a y and a w. And then, so I got rid of that. How do I get k by itself? Get rid of the x and the z. How do I get rid of those? Yeah, see how easy it is? All right. And now I got k by myself, so now I can just chuck those in here and then work it out. I think it's easier to do the algebra with letters than it is a whole bunch of numbers. Especially, I keep referring to this because this is what I remember, especially when you get into physics. Because when you get into physics, you're not just going to have a -3 and a 2 and a 4 and another -3. You're going to have 587.38, these crazy numbers, all right? And then to try to do algebra with all that stuff is a mess, all right? So to me, it's so much easier just getting the variable by itself, then you can plug everything else in. All right, enough of that. I'll keep harping on it because I think it's important. Now we can plug all these numbers in, right? It's yw, so y is -3, w is 4, x is 2, and z is -3. See how easy it is just to plug all that stuff in? And I think it was pretty easy to do my algebra to get k by itself right there. I don't know. Doesn't look like I'm convincing some of you guys. Or maybe you've already been convinced. You're like, just keep going, Mr. Hamrick. We've already heard it 10 times. And now you just work this out. Which one was this? Oh, yeah, okay, I see it. So what do we got? That's -12 over -6. That's easy. What's that? 2. So k equals 2. It's not what they ask for, though. Sam, help me out. What do they ask for? Find what? Find y. Okay, when x equals 4, z equals -7, oops, and w equals -4. Okay. Now, again, if you go to the original one, they already got y by itself, so you don't have to worry about getting y by itself. So we're just going to write y equals, and then it's kxz over w. Well, we just found k, which is a 2. And then x. What's our new x? Remember, our new x is what? It's 4. And then z, our new z is -7. And that's over w, which is -4. Can you do this in your head without a calculator? Yeah. So watch. Or it's easier than that. Look. This 4 goes into this 4, doesn't it? Okay. Now you do have a negative, so don't forget. Right? I'm just going to put it on top. Is that all right? Yeah. They cancel each other out, right? But you still, well, the negative won't cancel out with this. Well, that negative would cancel out with this one. If you wanted to do that, then that's fine. All right, a couple ways you could look at it. So that negative and this negative would cancel each other out. You could do that. And that 4 and this 4 cancel each other out. What are you left with? You're just left with 14. So y equals 14. It's not always that easy. Sometimes the numbers are weird, but you got a calculator, right? So put them in a calculator. Let's do one with a square. 24 or 23. They're pretty much the same, aren't they? Which one's more difficult? I think 23 is more difficult. Let's do 23. They're kind of the same, to tell you the truth. Let's just do 23. All right, Sam. A is what? Number 23. A varies directly with as the square of b. Okay, so let's stop right there. A varies directly as the square of b. So don't forget the k. The square of b, not the square root, but the square. So you're squaring the b. And inversely as c. Is that basically what it said? Yeah. All right, and then they tell you a bunch of stuff. They tell you A, B, and C. A is 45. B is 6. C is 12. All right, so what are you finding first? Finding K. So let's get K by itself before you plug the numbers in. So if I get K, so multiply by C, so I get AC, and then divided by B squared. Right, now you just plug everything in. So you got a 45, got a 12, and you got a 6, and it's being squared. I'll let you do the math on that. Comes out to 15. Yeah, it's easy. Right, that's 36, that's 12. So that goes into 36, what, 3 times? 45 divided by 3 is 15. Easy. You got it? Right, that's 36, right? 6 squared? Okay, so you got a 12 and a 36. 12 goes into 36 3 times. And then 45 over 3 is 15. Yeah. But we're not done. What's it say to find? Probably B. Find B when A, I'll put this, when A is 96 and C is 10. Now this time, B's not by itself, is it? So we got to get B by itself. Now, keep the B on the top. The B's already on the top, right? So I don't want to divide by that. Multiply by C. That's right. So watch. If I want to get B squared by itself, all right, I got to get rid of the C. It's being divided, so I multiply it. So that gives me an AC. It gets rid of that. How do I get rid of the K? Divided by K. But this is a B squared. So you take the square root. But remember what we do with square roots? Put plus, yeah, well, you do it both sides, but it's plus or minus. Plus or minus. Have we talked about that this year? For instance, what's the square root of 9? If I just said what's the square root of 9, almost everybody in here would say what? 3. Is it just 3 though? It could be plus 3 or it could be minus 3 because what number squared gives you 9? Well, 3 squared, right? But also negative 3 squared. Negative 3 times negative 3 is also 9. Yes? So you get a plus or a minus. That's why you get the plus or minus right here. Now, let's plug the numbers in. So you got a big old square root, plus or minus. You got A times C. So it's what? 960, correct? Divided by K. K is 15. And that gives you, I don't know, it just works out to be, well, probably 64. I'm sure it's 64 because the answer is 8. All right, so plus or minus. So what would that be? Plus or minus 8. So that is what B is equal to. These are super easy once you get used to them, aren't they? Yeah. So it was nice of them to put it at the end of the chapter, right? Nothing crazy hard. It's this thing right here. You got to set that up right, though. You good? Yes, ma'am.
For 3.7, we have to graph at all, or like read the graph and write the function.
I might. I don't know if I'm going to have you read the graph because it's very difficult for me to put a curvy graph, because I don't really have good software to do that. You saw what it looked like on that quiz. It looked pretty bad because I just made a photocopy from a worksheet and it just didn't look that good. I may try, if I do put that on there, where you have to read the graph and tell me, that kind of thing. I mean, I might just ask for like, what are the extrema, right? The maximum and minimum and that kind of thing. So I'll give you a graph or tell you or ask you where it's ascending, where it's descending. Oh, that's another lesson. Oh, this isn't the whole chapter, is it? This is just, okay. Right, that was the other quiz. Sorry about that. So what would we do on 3.7? Would I give you a graph? Was there anywhere on there where I gave you a graph? On not me, but the book. Did they do that? Yeah, 3.7. The only thing we did was that vertical and horizontal asymptotes, correct? On 3.7 it said that?
Yeah. Is it the last problem?
Bless you. Thank you. You're dragging it.
Yeah, I could. So, for instance, and it wouldn't be something that's like really difficult. Let me do this. Let me bring up Desmos. And we'll just do a real basic. I got to change this thing around so that we can see it. There we go. All right, so, I mean, what if I gave you like 1, or let me say y equals 1 over like x minus 3. Now, pretend you don't see that 1 over x minus 3, okay? We're kind of working backwards here, all right? So what if I gave you a graph that looks something like this? Because I haven't tried this yet. I haven't tried taking a screenshot of Desmos, so I may do that, take a screenshot of Desmos and then put it onto the quiz. So I could do something like that and maybe, yeah, I don't know. See, it doesn't give you like a lot of the graph when you can see the actual numbers, 1 through whatever. But what would this be? Like, forget this. Forget you're looking at this, okay? Just the shape of it. What is the parent function to this? It's just 1 over x. Y equals 1 over x. Everybody with me on that? So let's actually put the parent function in there. Y equals 1 over x. Okay, see the blue one? That's your parent function. What did I do to that red one? Again, don't look at this. What did I do to that red one compared to the parent function? I just moved it to the right, okay? And if you go up enough, you can see where that 3 starts going down like this. And this goes up to it goes up to the 3, but it doesn't ever hit it. So that's your vertical asymptote, right? So it's still a 1 over x function, but what did we do to that parent function? We just moved it to the what? To the right 3 places. What does that do to our equation when I move it to the right 3 places? I guess I could have done this. There you go. It hit it. All right, now you don't see it. So what is that red one compared to the blue one? It's the same as the blue one. It's still a 1 over x, but what did I just do? I moved it to the right 3 places. And how do you write that? If you look at it and say, okay, that red one's the same thing as the blue one, but I just moved it to the right 3 places. So it's 1 over what? It's x minus 3, okay? What if I move this, what if I wanted to move it 3 to the right and 2 down, then what would your,
Whatever x minus 3 minus 2.
and then a minus 2 at the end. Exactly. So if I put a minus 2 right there, see what it did? See, so this whole thing, I don't know how to explain it, but it went, there's the 3. Let me zoom in a little bit. So there's the 3. It never touches it here, never touches it here. But where's the horizontal? I wish I could like drag down a line, but I could do this. I could say x equals 3, and then I could also say what? Y equals what? What would the horizontal asymptote be? If I move that blue one to the right 3 places and down 2 places, what's the horizontal asymptote going to be? Look at the red one. It gets really, really close to what, but never hits it. And then right here, it gets really, really close to -2, but never hits it. So if I write y equals -2, see that? So what did I do to that red one? I moved it where? To the right 3 places and what? And then down 2 places. So I don't know. I think just technically, the technicalities of putting a graph on there that looks nice and pretty, and you're going to see the numbers, it's difficult for me to do that on a math test. Because I don't have a program where I can draw nice smooth lines and make it look nice and clean. I would just have to screenshot it, and that makes it kind of ugly.
Just turn that on and hide it like you did.
Yeah, but, well, I mean, I can, but see, to really see where it hits, you don't see a whole lot of the graph. You just see a little bit of that graph. And if I screenshotted that and shrunk it down, it's kind of hard to read. So, in answer to your question, I was kind of saying all this just to think myself whether I'm going to do that or not. I probably will not give you a graph and you have to identify it. I mean, I would like to be able to do that. The other way around, yeah, you should be able to graph something. Okay, so if I asked you to graph this red one right here, okay, let's get rid of that. If I asked you to graph the red one, the first things I would do is figure out what your horizontal asymptote and vertical asymptote are. Okay, and so how do you find out what your vertical one is? You set this equal to 0, right? So that would be 3. So x would be 3. So right there's your asymptote. And then right here, you know it shifts down -2, right? It goes down 2. So that means it's y equals -2. So once you have that, then again, you don't have to be like super accurate on the curve, right? Just give me some kind of curve that swooshes like this and it swooshes like this. Yeah, look. I probably won't give you anything crazy like that. I mean, really, if you... Here, watch. Let me copy that and put this right here and put like a 2 on here instead of... See that? It really doesn't change it a ton. I mean, it absolutely changes it, okay? But the curve still looks the same. I'm not going to be like super picky. Oh, you didn't go through exactly the point wherever, 4,0 or something like that, okay? I just want to see that you know what an inverse curve looks like if I ask you to graph something, okay? But I could definitely ask you to graph something like this. I probably wouldn't put a 2 on there or, you know, make it real funky. Just basic, just real basic stuff. Does that help a little bit? So I definitely could ask you to graph something for sure, right? And they're going to be inverse graphs. And so again, the important thing for the inverse graphs to know the 2 asymptotes, the horizontal and vertical. If you know those, then you just do a little whoosh and a little whoosh. Now, what happens when it's negative? What does that do? Let's do the red one. Let's forget the black one. What is it going to do to this? I'll tell you what, let's copy and paste it, and I'll put a negative. What do you think it's going to do to this red portion up here in the first quadrant? See, I'm taking a look at my 2 asymptotes, right? See this purple one and green one right there? So this one right now is in the first quadrant. If I put a negative out in front of it, what's it going to do? What's it going to do? It's going to flip it, right? It's going to flip it down, and it's going to take this one and it's going to flip it up here. So what quadrants are my two curves going to be in if I put a negative in front? In the, what's this quadrant? Look at my two asymptotes, the green one and the purple one, okay? What's this quadrant? What's the number of the quadrant? It's the second quadrant, right? So I got first, second, third, fourth. So instead of being the first, it's going to be in the fourth. Instead of being in the third, it's going to be in the second. So let's put a negative right there. And did that give me a color? Oh, there we go. Yep. Everybody see that? So that's what this did. It took the negative, took this red curve right there, and it flipped it over this axis. It took this red curve right here, and it flipped it over that axis. And it made it that. All right, so let's take that away. That's what a negative, see, I mean, that already looks fairly complicated, but it really isn't that bad. Again, when you're looking at this, how do I know how to draw this thing? Well, I know my vertical asymptote is going to be at 3, right? So I draw a vertical line at 3. I know it's going to drop down to -2, right? So that's going to be my horizontal asymptote, y equals -2. This is a negative, so instead of my swoosh being up here in the first quadrant, it's in the fourth. Instead of my swoosh being down here in the third quadrant, it's up here in the second. Do you see that? So you should be able to do that. Again, I'm not going to be super picky that you cross exactly at 2.5, 0, or right here at 0, whatever that is, -1.7. All right? I just want to see where you're putting those curves. It's a sketch. It's a sketch of a graph. It's not like a perfect graph. It's just a sketch of one. I wouldn't give you anything more difficult than that. That's probably as hard as I would give you something similar to that. Now, obviously, instead of putting +3, or instead of -3, what if I put a +3? What would that do to it? It would shift it where? To the left 3 places. So if I made that, whoops, not equals. If I made that right there, did I do it? Did it do it? Oh, I didn't make it. I didn't change it. It's got to be a plus. There we go. Now it moved. I was wondering. I kept it negative, and I was thinking it would move. All right. You see that? So now my asymptote, my vertical asymptote, is not at 3. Where is it? It's at -3. All right. Now I just put that in there. I mean, the program didn't put that asymptote in there. I just put it in there so you could see it. So the key to doing a problem like this is putting a vertical asymptote and a horizontal asymptote, and then just making sure your curve is going the right way. What if I shifted this up 2 and I put a plus? See what it did? Just shifted it up there. Of course, that changes my horizontal asymptote. So instead of y equals -2, what is it? Y equals 2, and there it is. Does that make sense? Yeah, it's not too hard, is it? I don't know. I might be able to screenshot something like this. You might be able to figure that out. Do you think you could? If I screenshot that?
No.
What? I don't know. See, and I don't know, because the colors are going to come blend into the grid. I don't know. Yeah, because it's going to be black and white, right? And so you won't really see the green and the purple. So it may not show up too well. I'll have to work on that, see if I can do something like that. All right, anything else? Remember the 3 things? Do I need to take the phone? Because it doesn't look like you're using it for proper reasons. All right, that's it. Go back and watch the video, the last video that I did on 3-7. Okay, you know what I mean? Okay, the one where we did the 3, you know, if, I'm trying to think of it off the top of my head. What is it? if the, let me flip back to it. Oh, I got it right in front of me. Yeah, the degree of the top is less than the degree of the bottom. Remember that? Then it's y equals 0. If the degrees are equal to each other, you divide the coefficients. And if the degree on the top is bigger than the degree on the bottom, there's no horizontal asymptote. So know those. Page 186, I'll be taking problems probably from page 186. Okay, that's on that 3-7 stuff. Okay, we have a video of it. You can go back and watch it. And the stuff that we did today. So that should be good. So I'm going to try to fit 10 on there instead of 5, all right, because these aren't that long, right? And I think we should probably be able to get 10 on there. All right. Is that it? Okay.